The daylight slope projection that extends from the edge of the road design to the sampled surface tends to change regularly along the design for a number of reasons. The more common are to avoid covering surfaces and to prevent excessive fill around trees. There are a number of ways to alter the batter projections. You can change the slope, make it steeper or flatter, set a fixed offset for the slope daylight to match the sampled surface, which will result in a variable daylight slope, set the batter line to an alignment, or apply batters with logic controls. The cross-section batters, or daylights, are currently being defined by the applied templates. We can readily add data in the batter data heading of the design data list to force an override to the default batter conditions from the applied template. To explore the various batter conditions that may occur, we're going to apply several different conditions along our road. The fixed width batter is applied at a distance from the centerline alignment of the road, so careful thought as to the appropriate width that should be taken. From the design data form, select the batter data heading and click on the Add button to add a new entry. The batter type selection list will open. Select Fixed Batters and click OK. In the Fixed Width from Centerline batter form, enter the following. Start station will be 0 and end station will be 100. Start left width will equal 30 and the start right width will also equal 30. Tick on constant widths. Then click on Add Update to apply the entry. From the Design Data form, click on the Rebuild Models button to update the surface. The cross-sections between stations 0 and 100 now display a batter fixed at 30 feet from the centerline of the road. The slope of this batter will vary to maintain that fixed offset. The slope batter is calculated from the end of the template on each side. Different slope criteria for cut and fill can be defined. Additionally, a maximum offset alignment can be used to limit the offset of the batter. From the Design Data form, select the Batter Data heading and click on the Add button to add a new entry. Select Slope Batters and click OK. In the Slope Batters form, enter the following. Start station will be 460. The end station will be 620. The side to apply will be left. The start left cut slope will be 5, and the start left fill slope will also be 5. Tick on Constant Slopes and click on Add Update to apply the entry. You can set a maximum offset of a batter to an existing alignment. If this was applied to this entry, ARD will hold the slope at 1 to 5 unless it intersects with the alignment, in which case it will steepen the batter to suit. From the Design Data form, click on the Rebuild Models button and update the surface. The cross-sections between station 460 and 620 now display a left batter slope of 20% from outside of the footpath. The offset of this batter will vary to maintain the 1 in 5 slope as defined when further design changes occur. Next, we will apply conditional two-section batters. This is a simple logical batter which creates a two-section batter condition. Designers specify offsets relative to the center line to an offset, normally the property boundary, and allow for two slope conditions, depending on whether the start of the section is in cut or fill. The second segment then batters from the offset to the sampled surface at a user-defined cut and fill slope. From the Design Data form, select the Batter Data heading and click on the Add button to add a new entry. Select Dual Section Batters and click OK. In the Dual Section Batters form, enter the following. The start station will be 100, the end station will be 200, the left width 30, the right width 30, minimum slope 50, maximum slope 5, the cut slope will be 2, and the fill slope will be 2. Click on Add Update to apply the entry. From the Design Data form, click on the Rebuild Models button to update the surface. The cross-sections between station 100 and 200 now displays a two-section batter comprising of a 2% slope when in fill, or a 20% slope when in cut, followed by a 1 in 2 slope back to the sample surface. This would allow for a positive slope of the road reserve towards the road for drainage purposes.